Hey, what's up? Chin here from Coding Quick Tips. Today with a new video on 2D side scrollers. In this video I want to show you the basic concepts of how you can get things done with user input and also the users or the players interaction with the level. So in this video we want to focus on stuff like the player can't run through walls and the player can't fall through the floor. So we will create a basic side scrolling mechanics that will include collision with the world and basic input like jumping and running. This video will also work for top-down games in that style, because you simply not have gravity and just have input for up and down instead of jumping. With that way you can easily adopt this to a top-down game too. So we will create something similar basically to what you can see here today. So yeah, let's get started. To start off, I got a simple empty project as every time, and I just got a function to draw those help grid to get us some idea of the coordinates where we want to draw stuff. To start off, I wanna separate the level and the player just to keep things a little cleaner this time, because it will be a little more code. So go ahead and create a new class for your level. So I will call this static level, as this will hold all our static level content, and our static level will have I will give our static level the basic methods like render, init, update, just so the level can handle all that stuff itself. So let me get rid of that. Here we go. Here we got a really basic static level class, and we will include that in the main game. So that's the first thing we want to do. We go in the main game class and we create a new private static level. What that will do is we will just call the methods from our static level, so we can work in there without messing our code up too much. So level equals new static level. Here we go. And we need to init the level. So that will do the job. With that, we just go and override the level's draw. Level.render method, and we will override the level's update method. So here we go. With that, we got the basic stuff set up, so we can jump into our level. So now we need to ask, what does our level consist out of? Our level is basically a collection of shapes that will define where the player can walk and where the player can't walk. So in my case, I will have two shapes. So that defines the level, so private shape. And one will be the level base or something like that, so the overall level. And the second one will be in platform floating in the level. So I'm gonna create those two. Level base will be one shape, and the platform will be the second one. So we need to include the shape from Slick. Here we go. We covered all that in a previous video. So if you are not common with Slick 2D collisions and Slick 2D shapes, please go back to the last video or one of these and have a look at that. You will get also info about shapes there. So I actually prepared the coordinates for the polygon and the platform. So here we go. We got a collection of points for our polygon, which will basically be the outline of our level. Then we create a new polygon with those polygon points, and we create a new rectangle for our platform within the level. That's really basic. We talked about that, so I won't cover that in too much detail. Our level should be rendered in a green color. You can actually render your level using other stuff like tile maps or I don't know, just images. But in this tutorial we will totally focus on the basic stuff, so the basic input handling, the basic collision and gameplay handling, nothing fancy. And we just want to draw both shapes in here, so we want to draw both our platform and our level base. Here we go. What that will do, if we quickly start it up, sets our level base, it's in polygon around the level, and sets our platform, it's in a rectangle. So that's really simple, nothing fancy about set. So with set created, we now have our basic level. One last thing we actually need to have in here is we need to have a method that will tell other objects if our level is colliding with them. So right now our level is just rendering. So it's just rendering, but it's not interacting with anything. So to make it interact with anything, I will create a method that our player will use later on to then handle collisions with the level. So I will call that public boolean, as we will return in boolean, collides with. And this will take a shape. So what I want this method to do basically is I want to say this will return true whether if the shape that is given here is colliding with our level. With that, we can later on go to our player and just say, is our player colliding with anything from the level? And that will speed up the process. But you will see that when we come to that place. So right now I just want to say we want to return whether our level base dot intersects with our shape. So then we want to return true, obviously. And we also want to return true, so, or our platform dot intersects with our shape. So what this method will do, it will return true whether our level base or our platform collides with the given shape. And we can use that in the player later on. Talking about the player, we want to create the player. The player will be the main focus of this tutorial, so I'm just gonna create a new class for the player. As in the static level, I want to have the basic methods within the player. Here we go. Just to have things, yeah. It's just easy to have those methods in here. So, what defines our players? That's a big question now. What makes our player, or what's important for the player? So, as we're building a 2D jump and run, our player has some basic some basic behavior that it has. It is basically jumping. Jumping includes how high the player can jump and how fast he will fall down again. And we have the basic left and right movement speed, which is a basic number of how fast our player can run if we want him to run left or right. So those are all the properties that define our player. So let's define some static variables as they are just static properties of our player. So let's go here, private static float gravity. Our gravity will be how fast our player will fall down. I will set that to 0.5 for now. We also want private static float jump strength. Yeah, I'll call it jump strength here. I'm gonna set this to -15. I will show you later why I do that. Those are just the basic properties of our player. I also want the player to have a speed. I will set the speed to 4. And also those are float values, so we can use them later on in the code. Another thing our player wants to have is it wants to have a shape that defines our player. So basically, we want to have a shape, and wherever the shape is, our player will be, and we don't want the shape to fall through our level. So let's create a private shape player. This will be the main part of our player that will actually be represented in our game code. So in the init method, our player should be initialized. I prepared something here because I don't want to type all that. So I positioned the player at 200, 200, and notice his size is 49 by 49. That's because if we go ahead and start, also blocks are 50 away from each other, and by making it 49 big, it can go through holes like this easily. It just takes a little bit of problems off or everything. If you finish the project, or if you get the code from Git, you can just play around with the value here, and you will see how it affects gameplay. But basically our player is just an box and rectangle on the screen that is defined by position and the size of it. Our player should also be drawn. Therefore we go to the render method. Our player will be drawn in a red color, so we set the color to red down here in the render method. And after that we just draw the player shape, which is also covered in the tutorial about collision and shapes. So here we go, we got our basic player. One last thing to notice, I told you just a little bit ago that this collides method is here to allow the player to check the collision against our level. To do that, our player will need to know about the level. So private static level. What that will do for us is we will have a reference to our level, and therefore we will be able to actually use this as a variable in our code to later on perform the movement actions and perform the interactions with the level. So to do that, I will just take a new constructor, public player, and it will take our static level. So here we go, and we set our local level, sys.level equals the new level that we just got. So here we go, we got our basic player, so let's bring that into our game. Private player, here we go. I suck at typing while talking. So our player equals a new player, that will take our level. And after that, our player wants to be initialized. So here we go. We also want to render our player, obviously. Player.render. And we want to update it. So player.update. So with that, if we start up, both our objects are loaded and rendered. Our player is rendered, our world is rendered, and everything works. But right now our player can't move and can't do anything. To change that, we will need to add some code to our player, as this will define what the player can do. So first of all, I guess I had a video about that, I had one, on how we can get basic movement done. We won't do the movement by directly manipulating the player's position or the shape's position, as that won't allow us acceleration in our game. But we want acceleration, obviously, for the gravity effect. For that, we want to have our player having a speed in x and y direction, or a velocity in x and y direction, and we will then use that velocity to change the position. I talked about that in the video how to simulate gravity in your game, so jump back to that video if you want to see more details about that. So our player will have an x and an y velocity, and at the beginning it will be 0. Down here, a very obvious task will be we will do the y. So let's do the y acceleration. We will change our y speed. So the first very obvious thing in the update method is every frame our player will get faster and faster in the y direction. He will be forced down by the gravity, or by gravity, To do that in code, we just say our y speed, sorry for that, our y speed will be incremented by our gravity constant every frame. What that will do is it will basically speed up our player on the y-axis every frame, so we get that nice gravity effect. So now we changed the y speed. We actually have to apply the change in y to the actual position. For that we will separate the acceleration of our player from the movement of our player, which will make stuff easier. So the y movement is quite obvious. Now after we got a specific speed of our player at this frame, we can say, well, we just need to change the player's position according to his speed. So let's do that. Let's say player.setY So we want to change set, and set will be player dot get y plus our y speed or our y velocity. What set will do, it will change the position of our player every frame according to the speed the player has. One last thing to notice here, I don't use the delta time in this video as I lock down the FPS to 60 FPS. I do that just for simplicity, as it will take off some writing, and maybe that could confuse some people. So if we start our game now, you can see the red box falls down. If we go into our code and see why it does that, the y velocity is increased every frame, so Z gets higher and higher. And then we just change the player's y position by the velocity, so it falls down. Yes, that's what we do. But what we will notice here is it falls through the floor, which is nothing we really want to have in here. So, and that's the most important part about the tutorial actually. It's on how to prevent the player from going through the floor. So to do that, we have a simple step-by-step instructions that will basically break down this process to some very simple steps. First step is move our player whether there is a wall or there isn't a wall. Second step will be check if our player collides with any wall or any level part. And if it collides, we know, hey, our player is not allowed to do that movement. So we just reverse the movement and that's it. So let's get this in code. So here we got our movement method. So what happens if our player gets moved down but it would hit the floor? So we can say that. So we can say if level dot collides with, notice the method we created earlier. So if the level collides with our player shape, then we know we just moved into the floor, because here we moved our player and after the movement we are stuck in the floor, which is not good. So what could we do to prevent that? Well, that's quite easy. If our movement was incorrect, we just reverse it. So first we added our y velocity, now we say, well, that movement was not correct, so just undo it. With that we will undo the movement, and one last thing, we will reset our y speed to 0 because we just hit the floor. So if I start that up, you will see, bam, our player is stuck to the floor. This is caused because now if the player would fall into the floor, give me a second. Let me get that down here. Yeah, here we go. If the player now would get into the floor or fall into the floor, we catch that up with that if statement right after we did the movement. We reverse the movement and say, nope, don't go there, just don't do it. And with that it will work quite well. With that method, one thing to notice is it's not that accurate, but I will deal with the problem in the next video in detail. In this video I just want to get the basic message over, and the next one will be a really small correction on how to get it even better, but that will do for a really basic game. So if we start this again, we can see, bam, our player is stuck to the floor, which is, well, great, because it works. It's not going through the level. Wow, sorry for that. It's not going through the level. The next thing would be we want some input. So what are the basic inputs? One of them is for sure jumping, and the second one is moving left and right. So in this video I will go on implementing going left and right, and in the next video we'll implement jumping and we will make the movement smoother. So first thing to do is we want to have a new separate section, our code for the X acceleration, as we will just split up the X and Y movement again. So what I will do here is, our X movement is quite obvious. So I got something prepared here. It's just, here we go. Oh, that sucks. So what that does is basically we check, is the left key pressed? If it's pressed, we set our X velocity to minus speed. If the right key is pressed, we set it to speed. So we basically set the player's velocity to either make the player move left or move it right. And we directly set the velocity here, as our movement has no acceleration, as most side-scrollers or most jump-and-runs don't have acceleration on the left-to-right movement, as this just gives you more accurate movement as a player. It feels more accurate. And if we have not hit any of those two keys, then we're not moving left or right, then we set the velocity to 0. And for the movement, and that's actually the sweet part about all that is, we could just go ahead and copy over the Y movement, and that's a nice thing. Also, this will work quite similar. We just say, now it's our X movement. Now we will change our X position according to our X speed, our velocity X that we have set up here, that we have bound to our keys basically. And if we fail moving in the X direction, we just do the same thing as before. We undo the movement. Here we go. I won't reset the speed of the X thingy here because yeah, we can do that. It will work also. So what that will do is we basically change the velocity in X direction according to our input, and then we apply it the same way we have done up here. We move the player, and yeah, let's start the game. We can move the player left and right by hitting the left and right keys. And if I go into a wall, the player will try to move into the wall. But here we say if our player was moved into the wall, we will just undo the movement and set our velocity back to 0 and just undo the movement. With that, we can't move into the wall, and it works quite good. One thing you might see here, I don't think you can see it on video, is we got a little bit of space here. If I increase the speed, you will be able to see it better. So let's get the speed up to 10 maybe. Yeah, you can see we got that spacer here. And the same thing is with falling down. If we wouldn't set the velocity to 0, you would also see that spacer on the bottom when falling down. And that's a thing we will cover in the next video, as well as jumping. The main thing you should take from that video is the basic process of handling collision in such a game. It's basically move the player just as there wouldn't be a level, then check if the movement was valid, and if it wasn't valid, just undo the movement. With that, you can basically get the movement working quite well. Yes, that wraps it up for this video, I guess. We got a basic input and basic movement. Next video will be jumping and more accurate movement. And yeah, I really hope you enjoyed. If you enjoyed, please thumb up for the videos, that helps me a lot. If you haven't enjoyed, please let me know why you haven't enjoyed in a comment. And if you want to see more tutorials, or you're just interested in indie games, creating games, or programming, then think about subscribing to my channel, as that will also motivate me and help me a lot. With that said, I really hope you enjoyed, and I will see you next time.